Hello and welcome back to another math video. We're talking about the volume of prisms right now. So in general, when we think about the volume of a prism, we want to think about what shape is being stretched in what direction. And I know that sounds weird, but let's think about this for a second. If I think about a rectangular prism like I have down here, we can think about this object as having a base. So it's got a base. And all we did was we took that base shape, and we stretched it in the vertical direction. So when we stretched it in the vertical direction, we ended up getting something similar to a rectangular prism. And we can say similar things about any sort of prism. For example, a cylinder. A cylinder is a circle that's been stretched in a vertical direction. Holy guacamole, that's a terrible cylinder. But hopefully you can understand what I'm talking about. Same as a triangular prism, but let's draw the triangular prism on its side here. And if we stretched it in a horizontal direction, then we could get the same thing. Whoop. Good. So hopefully you can kind of see, I'm not much of an artist, but hopefully you can kind of recognize that it doesn't matter what kind of a prism that we're talking about. We're thinking about what kind of a shape did we start out with, and in what direction did we stretch it with. So the volume of any prism, doesn't matter, rectangular prism, triangular prism, cylinder, whatever, the volume is going to be the area of the base times the height. Now we could talk about the height, or we could talk about the direction that it was stretched in. I think it's just kind of best to talk about this as an example. So it says determine the volume of the following shapes, and we have a rectangular prism here. As we can see, or hopefully you can see, this object has a base, and the base was stretched in a vertical direction, and that's why we ended up with a rectangular prism. So, okay, that's great. No problem. But how do we calculate the volume of this thing? The volume is the area of the base times the height that it was stretched in, or the distance that it was stretched in. Well, what's the area of this object? The area of this object, of the base of it, is length times width, and we're multiplying it by height. Oh, okay, well that makes sense. You probably should have known this. So the volume is the length times the width times the height. Well, that's pretty darn easy. Our length is 10 centimeters, our width is 6 centimeters, and our height is 4 centimeters. So when we get centimeters times centimeters times centimeters, we're going to get centimeters cubed. And when we get 10 times 6 times 4, 6 times 4 is 24, 24 times 10 is 240 cubic centimeters. So what that means is if we were to try and fill this thing with little tiny cubic centimeters, we'd be able to fit 240 of them all the way up in this object. We've got another example here, except this time it's a triangular prism. Hopefully you can kind of recognize that we've got a triangular shape on the bottom, and it was stretched in a vertical direction. So the volume is the area of the base times whatever direction it was stretched in. The area of the base, that's a triangle, so it's going to be base times the height of the triangle divided by 2, and then times the height of the prism. We have to recognize that those heights are different. So what is the base of this triangle? Well, the height, I see the height is here. It's that dashed line in the middle of the triangle, so that's 5 inches. So that means that the base has to be that 9 inches that the height is coming off of. So the base is 9 inches, the height is 5 inches divided by 2. and then we're multiplying by 14 inches. We're going to get inches cubed. And when I punch this into my calculator, 9 times 5 times 14 divided by 2 is 315 cubic inches. Looks like we have another rectangular prism, but it's a very special rectangular prism. When I look at this, all of the sides are equally long. So again, this is a prism, right? It's the area of the base times the height. Well, what is the area of the base? The area of the base is 4.6 times 4.6, so that looks like it's length squared. And then we're multiplying it by the height, but the height is the length again. So it's really just length cubed. Hopefully that makes sense. The volume of a cube is whatever the side length cubed is. So that means we're going to get 4.6 cubed. And when we do that calculation, we're going to get 97.336 cubic meters. Another example, we've got, says round the answer to the nearest tenth of a cubic meter. So we probably want to express everything in meters straight out of the gate. Oh, I see that I have a diameter that's 90 centimeters. Let's change that into meters. So that's going to be 0.90 meters. But that's the diameter. Okay. Let's try this out. The volume of any prism, and a cylinder is technically a prism. So it's the area of the base times the height that it's been stretched in. So the area of the base, what is the base on here? Well, the base is a circle. So that's pi r squared, and then the height of the prism. So we know what pi is. Pi is 3.14159 something, something, something. We don't really know what the radius is. We know the radius is half of the diameter, so that's 0.45 meters. So 0.45 squared. And then the height is all the way up here. It's our 3 meters. And when I get this, or when I put this into my calculator, I end up getting 1.908517537 cubic meters. It says it wants to round to the nearest tenth of a cubic meter. So the tenth of a cubic meter. So here's our tenth. And it looks like the 9 was definitely not going to round up. So our volume is 1.9 cubic meters.